So module 4, we'll move on to acids and bases. So with acids, they historically have a sour taste. You know, on the pH scale, something that's acidic is less than 7. It releases a hydrogen ion. So for instance, HCl, which is hydrochloric acid, when you put it in an aqueous form, it will dissociate, which means it'll break down into H plus and Cl minus. And we call this a strong acid. And there's 7 that are strong acid: HBr, HI, HNO3, H2SO4, HClO3, HClO4. And if it's not a strong acid, it's going to be a weak acid, which means it does not dissociate as much as HCl or the strong acids. The hydronium ion, H plus, and for our class, H plus is analogous to H3O plus. You break down the HCl, you put it in water, you get H3O plus or Cl minus. And in our case, it's equivalent to HCl breaking down to H plus and Cl minus. And we refer to the hydronium ion as H plus. And bases is the opposite. We have a pH greater than 7. And when you put it in a base in water, you get OH minus as a product. And it has a bitter taste. And we have these strong bases, which is anything in the group 1 or group 2 from the periodic table that reacts with OH will give a strong base, and anything else will be a weak base, such as ammonia is an example of a weak base. So when you have a strong base reacting with a strong acid, so for instance, if you pour a strong acid, HCl, on your kitchen counter, how do we stop it from eating your counter? We would add a base. We would not add more water. We would add a base because it will neutralize. The strong acid and the strong base will give us water and salt. So this would save your kitchen counter if you dropped a strong acid on your kitchen counter. We just discussed briefly a molecular formula, which is HBr, and as an example, which is a molecule and a molecule giving a molecule giving a molecule. But you can also break this molecular equation into ionic equation, which means you break them down into ions. So the H would break down to H plus. We know Br is a Br minus from the halogens. The Ba would be Ba2 plus because we know Ba is a group 2A element, and the OH minus here. So these would all be ions. And if we wanted to have a net ionic equation, that just means we cancel whatever is on the left and the right. So here the Ba's will cancel, the Brs will cancel, and then we're left with H plus, OH minus giving us water. This would be our net ionic equation. And as I mentioned briefly, we can judge our acidity on a pH scale. And the equation we use to measure the pH is negative log of H plus. So if the concentration of H plus was 1 times 10 to the minus 7 molar, we plug this in here into your calculator, 6 zeros, and you hit the log button, multiply by -1, this would come out to pH 7. So if you have time, give that a try on your calculators. And if you compare something like pH 2 versus pH 3, the difference between those two is a factor of 10. So pH 2 is 10 times more acidic than pH 3. Another equation that brings together H plus and OH minus is this Kw value. And all that's telling us is at 25 degrees, we have a Kw, which is a ion product constant. it brings together H plus and OH minus. So for instance, if the pH is 7, you'll have 1 times 10 to the minus 7 H pluses and 1 times 10 to the 7 minus 7 OH minuses, which gives us our 1 times 10 to the minus 14 constant. This stays constant, and you can actually adjust these values, the H plus and OH minus. But as I said earlier, the H plus, when the H plus is more than the OH minus, we have an acidic solution. And when the H plus is less than the OH minus, we have a basic solution where the pH is greater than 7. Here's a pH scale and just giving you some examples of what is acidic and what is basic. We've talked throughout this class about environmental issues, and rainwater is a issue as well. And how does that form? Well, the carbon dioxide again in the atmosphere will dissolve in water, react and dissolve in water, and to produce this carbonic acid. And this carbonic acid can actually dissolve to H plus and HCO3 minus. And it's this H plus that is acidic from the rain. So again, stemming from CO2 again. We also have nitric acid that can form, and sulfuric acid can form. And these again are from pollution sources. The sulfur oxides, which we talked about earlier. The nitrogen oxides, they can react with water to form HNO3 and H2SO4, and eventually breaks down into the acidic H plus ions. So again, very detrimental to the environment. So this accumulation of H plus can be considered hazardous or harmful because we have the buildup of CO2, which produces H plus when with water, and we can see a lot of this is accumulating in the oceans. So something else to be mindful of. That concludes our module 5.